Okay, speaking of special right triangles, this next section uses special right triangles, and they want, they don't say exact answers, but what we do want is exact answers, and they're saying leave it in radical form. So because this is a 30-degree angle with a 90-degree angle, I know I can find these exact lengths. If this wasn't 30 degrees, if it was something like 29 degrees, I could use some trigonometric ratios to come up with these sides and get decimal answers. But we should be able to come up with exact answers here because this is a 30, 60, 90, because it's a special right triangle. So they've given us the hypotenuse of 20. The short leg is half of the hypotenuse. So A is going to be 10, and the long leg is whatever the short leg is times root 3. So the long leg is going to be 10 root 3. Now we can compare this to our problem 17 up above and see if we followed the pattern correctly. The short leg being 10, hypotenuse is twice that, yes, x and 2x, and the long leg being whatever the short leg is times root 3, we've got it. Let's try number 19. This is also a 30, 60, 90. Because there's a 30 and a 90, I know the other one has to be 60 degrees because they sum to 180. They've given us, in this case, the long leg. I should have thought of this a little bit more before we did this together so I could come up with a fast way to show you. To come up with the short leg, what we need to do is divide this by the square root of 3. So if I take 6 divided by the square root of 3, typically what we want to do is make this so the denominator doesn't have a radical under it. This is technically a correct answer, so if you put that for C, I would give it to you. But we oftentimes will rationalize the denominator, make sure that it's not a radical. So if I multiply this by root 3 over root 3, which is 1, something divided by itself is 1, it doesn't change the value of this, but it's going to change the look of it. So the numerator now becomes 6 root 3. And the denominator becomes square root of 3 times square root of 3, which is square root of 9, and the square root of 9 is just 3. Now here I have 6/3, and 6 divided by 3 is 2. So another correct answer for this is 2 root 3. Okay, I would have accepted 6 root 3 as well. Maybe would give an extra credit point if you came up with this one, possibly. So then if we've got the short leg, to find the hypotenuse, it's just double the short leg. So 2 root 3 doubled is going to be 4 root 3. All right, let's try number 20. This one has a 45-degree angle and a 90-degree angle, so this is a 45, 45, 90. And we knew that if we were given a leg, that the hypotenuse is whatever the leg is times root 2. So to go backwards, I need to take this divided by root 2 to get to that. 14 divided by root 2. That is a fine answer. You could leave it right there. Or if we want to rationalize the denominator, which is what I'm going to do, I multiply it by root 2 over root 2. That way when I multiply this across, my denominator is going to be a number without the radical symbol. Because I'm multiplying by square root of 2 over square root of 2, which is just 1, it doesn't change this value. So this is the same as 14 root 2. Root 2 times root 2 is going to be the square root of 4, and the square root of 4 is 2. Now I'm looking here to see if I can reduce, and I can. 14 divided by 2 is 7, so these legs are going to be 7 root 2. Because it's a 45, 45, 90, then those two legs are congruent to each other. We have an isosceles triangle. All right, over here, we have another 45, 45, 90 triangle. They've said that this leg is 7, so leg over here, G, must also be 7. And according to the pattern that we came up with in problem 17, I'll shift up so that we can see that. To find the hypotenuse, you just take leg times root 2. So back down to this one, since the leg is 7, h is going to be 7 times root 2. Our final answer is just 7 root 2.